My name is Mohammed Haris and I'm from Mechanical Engineering 1-8 session under the registration number of 2018 ME 162. The topic of my presentation is plasma arc cutting. This is a very commonly used cutting technique and is a non-conventional method. My presentation would primarily encompass the following points. First, we will discuss that what is plasma and plasma arc cutting. I think before diving into the deep details, we must know the basics, and then we will look about the types of plasma arc cutting. Next, we will see how this process is carried out, what equipment we use to cut metals by the help of plasma, and then we will see the sequence of processes that are carried out in order to achieve the final desired shape, and then we will see that what gases are commonly used in plasma. Next, we will see or we will highlight some of the advantages and disadvantages of this process. And last, we will see that where this plasma cutting could be used to achieve the practical purposes in daily life. And this will also conclude our presentation. So, starting from very first thing, or what I should call a very basic, is what is plasma and plasma arc cutting. So, if we divide the plasma arc cutting, it is actually a combination of three words, is plasma, arc, and cutting. Obviously, the cutting is very basic. The two terms left are plasma and arc. So we should know that what these plasma and arc is. Before that, I would even like to state the basic definition of plasma arc cutting, which is the use of heat that is generated by an arc between the electrode and workpiece for the purpose of cutting metal is termed as arc cutting, or more precisely, plasma arc cutting. Here, the words that are put in inverted columns are of great importance. That is heat, electrode, and workpiece. Heat is actually the thing that is used to cut the metal, and the remaining other two things we will look into them in more detail in the slides ahead. So the next thing is what is plasma. Plasma is basically the fifth state of matter, and this is superheat electrically ionized gas. So these are the things that are of importance. First, it is superheat. Second is it is electrically ionized, and this is the fifth state of matter. And this is generated between the positively charged workpiece and negatively charged electrode, as we will see in the slides ahead. So these are the definitions of arc, plasma arc cutting, and what plasma is. So moving back, and here we have types of plasma arc cutting. Although there are numerous types of plasma arc cutting, and this list is by no means exhaustive. We can add as many types of plasma arc cutting as we want, but here we have listed only three basic types that are more commonly used as compared to other types. And here our focus would be definitely on plasma arc cutting. We'll see that how this process is carried out in next slide. So before seeing the process, we must know that what equipment and what is the arrangement of equipment that we use for plasma cutting. And here I would like to highlight some of the terms or some of the labels on this diagram. The very first thing is plasma arc torch. This is basically the torch from where the stream of plasma is generated. And this stream of plasma is used to cut the metal. And the second thing is this tungsten electrode. And one should keep this thing in mind that this is always negatively charged and the workpiece is always positively charged. And as these are oppositely charged, so the heat that is generated between them is used to cut the metals. And the next thing that is of importance is the standoff distance. This is very important. This is actually the distance between the nozzle or tip of the nozzle and between the workpiece. And this distance could be varied depending upon what type of desired shape or what type of cut is required. This thing is curve. We will look this in our next slide. And these are all of the labels that one should be aware of before looking at what actually the plasma arc cutting is and what apparatus or equipment do we use plasma arc cutting. So, moving back to our home page, and the next slide is a process, that what process or processes are carried out to achieve the desired cut on the metal surface. So these are the three processes that I have listed or have summarized, that if you want to achieve a particular cut on the workpiece. The very first, you have to project the high velocity plasma stream whose temperature ranges from 10,000 degrees Celsius to 14,000 degrees Celsius. That is remarkably a high temperature value. You have to project this high temperature plasma stream on the workpiece, and that movement of the nozzle or the plasma stream could either be manually controlled or it may be a numeric control. But here one thing is pertinent to mention, that if you want to save time and if you want the precision to be more, you must go for the NC or numeric control. The next step is a kind of a process, is a kind of information, that is metal that are about 6 inches in thickness can be cut by this process of plasma arc cutting. Although it is a kind of advantage, but here I have mentioned as this is pertinent to mention because I have to explain the curve too. So in this, this I have written the word curve. This is actually the width of the cut that is produced by plasma arc. The width of the curve that is produced by the plasma arc is termed as a curve. And in the next slide, I think I have already explained this. This is a standoff distance that can be adjusted accordingly depending upon the requirement and depending upon the procedure. So moving back to our home page, the next slide is commonly used gases. Actually, the plasma is, as we have seen, that is highly ionized gas. So there's no specification or there's no constraint for that gas. We could either use nitrogen, we can also use argon and oxygen, and similar is the case for hydrogen. And even we can use the blend and combination of these gases depending upon the requirement. Sometimes the water is also used, and that is basically used to remove the metal pieces of the debris that are actually left when the plasma cut the metal, and that is what you call shortly for the purpose of cleaning. And this is all about commonly used gases in plasma. And moving back, we have here the pros and cons. Here are the pros and cons of plasma arc cutting. So first we will look the what are the advantages of this process over the other process that are available in the market. So the very first advantage is a small risk of distortion. Like this process is highly accurate and the plasma arc is very high in accuracy. There is a very small risk that your metal piece or a work surface could be damaged, and there are the very less probability of distortion. The second pros is that it is easy to use in all operations. Like you can cut the metal surface at different angles. You can give your plasma tool a different shapes depending upon what type of cut and what type of shape you want on your workpiece. And last but not the least is this metal cutting operation is very common with the metals. Like it can work with all kinds of metal, and this is a very big advantage of plasma arc cutting. Like you can cut whatever metal you want. And moving to the cons or disadvantages of this process is, like as we have seen, the electricity is involved in this process. So there's a very high risk of electric shock if you're not operating the machine uh, by following the safety measures or safety precautions. The second thing is that it required a clean air source for the purpose of ionization. And last but not the least disadvantage of this is that the cut surface is somehow rough, and this is a very big disadvantage. That's why if you are going to prefer some other method over plasma cutting, then this will be the major reason behind that, or this will be the root cause of that. So moving back, we will see that what are the applications of this process. First, like as I have mentioned, that this is non-conventional cutting process and commonly used, so it must have application. And I've already mentioned that this process is very common for cutting of metals. Like we can see, it can use to cut stainless steel, that is believed to be the hardest metal, and that is prepared with a blend of different kind of metals. And then we will see it is used for stack cutting, like you can stack the metal and then cut then that. And it is used for making holes, that is actually piercing. And aluminum is also cut because aluminum is very thin and it can create a very fine cut over aluminum surface too. So moving ahead, and these are some of the references from where I have taken these images and all the data. And this brings us to the conclusion of our presentation too. Thank you very much for your attention.